Good morning to everyone. My name is Venkateshwar Rao, lecturer in computer science, Government Polytechnic for Women, Mumbai. And the subject is programming in C for second semester. And today we are going to discuss about algorithms and flowcharts. And the objective for today class are steps involved in algorithm development, and we'll discuss about the difference between algorithm and flowchart, and also we discuss about developing simple algorithms. Okay, and also we discuss about the differences between algorithm and flowchart. So first we discuss about the steps involved in algorithm development. We'll discuss about the steps. See, while writing algorithms, okay, the following notations are considered. Okay, we have to consider about name of the algorithm, step number, and explanatory comments, termination. Okay, these notations are to be considered. See, name of the algorithm is nothing but it specifies the problem to be solved. It is the name of the algorithm is the name, or it specifies the problem to be solved. And the second notation is step number. See, this step number identification tag. It is identification tag of an instruction. See, if every instruction is given a specific identification tag. Okay, and it is an unsigned positive integer. So we give an integer value for the step. First step, second step, third step. So these are nothing but unsigned positive integers. And the third notation is explanatory comment. Explanatory comment. So it follows the step number and describes the operation. So this explanatory comments describes the operation. See what operation is going to do. It explains what the operation is going to do, or what the step is going to do. And it should be written within a pair of square brackets. So here we use a square bracket for explanatory comments. So whatever we written in a square brackets, those are the explanatory comments. This explains the step. As explanatory comments explains the step, what the step is going to do, or what the operation the step is going to do. And the last notation is termination. So termination specifies as the end of the algorithm. It specifies the end of the algorithm. So it generally a stop statement and the last instruction in the algorithm. So this is termination is the last statement in the algorithm. This is the termination is the last statement in the algorithm. So these are nothing but notations which we use to design the algorithm. Say let us take one example here. Okay. Say algorithm to compute a area of a circuit. Okay, algorithm to compute area of the circuit. So here this is the first notation. Name. There is a name of the algorithm. This is the name of the algorithm. First notation. And these are the steps. These are unsigned integers. Step 1, step 2, step 3, step 4. These are the unsigned integers. We call it as the step numbers. And these are the explanatory comments. So explanatory comments which are written in square brackets. So this square brackets explains what the step is going to do. So this explains compute the area. It means it is explaining this statement is going to compute the area. This is a formula for the area of a circle. Okay. So this is another comment. This one is another explanatory comment. Print the area. So this statement print area of the circle area. This statement is going to print the area value. The area value of the circle. And the fourth step is that is the end, or we call it as the end of the algorithm. So stop represents the end of the algorithm. So let us see the first step. The first step tells read radius. So to find the area of the circle, okay, we have to know the, or we have to define the value of the radius. So that value is to be read, that is the radius value. By knowing the radius value only, we can calculate the area of the circle. Okay, see the formula for the area of the circle is, okay, that is pi r square. Okay, pi means 3.142 into radius into radius. R square means R is the radius value. Radius into radius. So this is a formula to calculate the area of the circle. Second step computes, or it will calculates the area of the circle using this radius value. 3.142 into the radius value, again the radius value. This will calculate the value, or the value is in stored in area. See here, and then here in step 3 we are going to print the value. We are going to print the value. What we are printing? Area of circle colon. See, this is the area value. What the value we are getting here? Whatever the value we are getting here, that is the, we are printing area of a circle, and then the value which we are getting from here. The last step is the stop. This is the, it represents the end of the algorithm. It represents the end of the algorithm. So this is the simple algorithm to calculate the area of a circle. And next we see the algorithm for arithmetic operations, basic arithmetic operations. And the basic arithmetic operations are addition, subtraction, multiplication and division. Okay, multiplication and division. So this is the division symbol here. This one is the division symbol. So here the first step is read the value of A and B. Here this is the comment, explanatory comment. Here we are reading the values A and B. Okay, first number is stored in A and second number is stored in B. Two values A and B. And here this comment is saying that compute sum, difference, product and quotient. Okay, we are going to calculate sum, difference, product and quotient. And then we are going to print the values, print the result. That is, print sum of A and B, sum of A and, or sum of A and B. That is but nothing but the value which we are getting from here. Okay, that is sum of A and B is equal to the value which we are getting from here. And next here print difference of A and B. So difference of A and B nothing but the value which we are getting here, the difference value. And next the product of A and B. Product means the value which we are getting here, that is that product value. That is the product value. And here the quotient value which are getting from this equation, that is A by B. From here we are getting the value, that is the quotient value. And then the last step is end of the algorithm. So end of the algorithm nothing but here it stops. Stop represents the end of the algorithm. At first step the algorithm is started. At the fourth step the algorithm is ended. And these are the comments, explanatory comments. Okay, comments are used to user understandable purpose. Comments are used for user understandable purpose. Next, we will see another algorithm, that is calculating the simple interest. Okay, so this is the first notation, that is the name of the algorithm, step number, explanatory, comments, and end. These are the four notations. What are those? These are the name of the algorithm. Okay, step numbers, explanatory comments, and end of the algorithm. Okay, so here we are going to calculate the simple interest SI, simple interest, and also the compound interest also. We are computing simple interest and compound interest. Okay, this is the P is the deposited amount, and some year T is the represents the year, number of years, and R represents the interest rate. Okay, P is the principal amount. P is the principal amount. So here what's the first step is saying us. So here the first step represents read P comma R comma T. So to calculate the simple interest, to calculate the compound interest, we need these values: principal amount, rate of the interest, and number of years. Number of years. Okay. So here, in second step, we are going to calculate the simple interest. Okay, this is the comment. This comment is saying that compute the simple interest. This says that we are going to compute, or we are going to calculate the simple interest. And the formula for simple interest is P into R into P by 100. PTR by 100. SI is called PTR by 100. So this will calculate the simple interest. In step 3, so we are computing the compound interest. Compound interest. And the formula for the compound interest is CI is equal P into 1 plus R by 100 to the power of N minus P. This is the formula to calculate compound interest. Okay, and then in step 4 we are going to print the value. Simple interest value and the compound interest values are going to be printed. That is, so here print simple interest. Print simple interest is called SI. SI is the result which we are getting here. And here print compound interest, the value which we are getting from here. CI value, compound interest. And then end of the program, there is a stop. Stop represents the end of the program. Okay, see, by using the principal amount, rate of interest, and number of years, we are going to calculate simple interest and compound interest. SI represents the simple interest and CI represents the compound interest. And this is the end of the algorithm, or stop represents end of the algorithm. And next we see another algorithm to find the largest of three numbers. This algorithm explains, okay, finding the largest of three numbers. Among the three numbers, we are going to find the largest number. So this is the name of the algorithm. Same, this is the name of the algorithm. These are the step numbers. These are the explanatory comments, and this is the end of the algorithm. Stop represents end of the algorithm. First, we see about the first step here. Read the value of A, comma, B, and C. We are reading the values. This comment says that we are reading the values A, B, C. Among the A, B, C, we have to find the largest number. So here in step 2, compare A and B. We are going to compare between A and B. First, we are comparing A and B. If A is greater than B, if A is greater than B, we have to check this condition also. A is greater than C condition also to be checked. Okay, if A is greater than B and A is greater than C, then only we can say that A is the greatest number. So what happening here? If A is greater than B, go to step 4. So go to step 4. What step 4 is going to say? Compare A and C for largest. See here, if A is greater than C, then ultimately A is the largest. If A is greater than B and A is greater than C, Finally, we can conclude that A is the largest number. Okay. Say if this condition is not true, if A is greater than 0, A is greater than B condition is not true, then go to the step 3. So what we are going to do in step 3? Here we are going to compare B with C. Here we have to compare B with C. So here, if B is greater than C, if B is greater than C, then B is the largest. If this case is false, then we go to the step 3. So here we are checking B is greater than C. If B is greater than C, if A is not greater than B, then only we move to the step 3. In step 3, we are checking B is greater than C. So by finding or by knowing this, we can conclude that the biggest or the largest value is B. Else if B is greater than C is false, then ultimately C is the largest number. C is the largest number, and then go to step 5 and then end it. See, when the step 3 is going to execute, if the step 2 is false, then only it goes to step 3. Then only it goes to step 3. Okay. So, see, in this way, we can calculate or we can find the largest of 3 numbers or largest number among the 3 numbers. Okay, and finally, so this is the step 5. Here we are ending the algorithm. Stop repeaters, the end of the algorithm. Okay, so this is the another example, and now we discuss about the symbols used in flowchart. Okay, to draw the flowchart, okay, we need some symbols. We need some symbols. First, we discuss about flowchart. What is a flowchart? So this is a chart showing a flow of logic involved in solving a problem. So this flowchart represents the flow of logic. It shows or it explains the flow of logic involved in solving the problem. So this is defined for an algorithm. This flowchart is defined for an algorithm. Every algorithm has a flowchart. Okay, and a flowchart can be defined as a diagrammatic representation of an algorithm. This is the definition. Flowchart is nothing but it is the diagrammatic or pictorial representation of an algorithm. Algorithm is shown in pictures, that we call it as the flowchart, and it is referred to as a blueprint. It is a blueprint for the algorithm. Flowchart is a blueprint for a algorithm. It is also defined as a visual or graphical representation of an algorithm. We call it as the graphical representation of an algorithm, or diagrammatic representation, or pictorial representation. There are 3 different. Flowchart is the graphical representation of the algorithm, pictorial representation of the algorithm, or diagrammatic representation of the algorithm. Okay, that is the definition for the flowchart. And the flowchart is an easy way to understand and analyze the problem. So to analyze the problem, flowcharts are the best way. These are the best way or easy way to analyze the problem. It is a useful aid for programs and system analysts. It is a machine independent. It cannot be used for any type of problem. It can be used for any type of problem. Flowcharts can be used for any type of problem. Each and every algorithm has a flowchart. And flowcharts are classified into 2 types. One is the program flowcharts and second one is the system flowcharts. So the flowcharts make use of geometrical figures to specify a particular operation. So here we use the geometrical figures. Okay, let me see what are these geometrical figures. Okay, see, following shows the different geometrical figures used to design the flowchart. Okay, and also it is showing the function of each and every geometrical representation. This is one geometrical representation. This is one geometrical representation, and this is one geometrical representation. This is one and this one. All these are the geometrical representation. So the name of this geometrical representation is oval. This shape is called oval shape, and the purpose of this oval shape is It is used to represent start and stop. It represents the start and stop. And the second geometrical representation is this symbol. This is called parallelogram. So this parallelogram is used for input and output operations. To give the input and to get the output, we use the parallelogram symbol, or we call it as the geometrical figure. And the third one is, it is a rectangle. This is the rectangle. So rectangle shows the processing of the data. This shows the processing of the data. How the data is going to be processed. That is shown by using this geometrical notation. And the fourth one is the rhombus symbol. So this is the rhombus symbol. Okay, the use of this symbol is, it is used for decision making. For decision making, we use the rhombus symbol. Okay, and the fifth one is arrows. This is the up arrow, down arrow, right arrow, left arrow. These are the arrows, different arrows. These are used for connections. Arrows will connect different geometrical notations. Arrows connects other geometrical notations. And then the last one is a circle. So this will represent the continuation of the flow. This will represent the continuation of the flowchart. So all these are the different geometrical notations or figures used in flowchart. So next, see, these are the explanation for those geometrical symbols. The first one is a oval. This is a rounded rectangle. Oval is also called as rounded rectangle. This will shows the starting and ending point of the process. This shows the starting and ending of the process. And parallelogram represents the input given to the process or an output generated by the process. To give the input, okay, and to read the output, we use the parallelogram. Parallelogram. The third one is a rectangle. So rectangle, it is used to process it is used to process the information or data. Rectangle is used to process the information. And the fourth one is a rhombus, or we call it as a diamond symbol. So this renders the decision point. Rhombus is used for decision making, like true, false, yes, no. For that purpose, we use the rhombus symbol, or we call it as a diamond symbol. And the fifth one is the arrow, or we call it as a flow lines. So these are the left to right or top bottom line connecting symbols. These are the left, right, top or down. These are the different connecting symbols. This line shows the flow of control through the program. So this shows the flow of control or flow of data among or between the other geometrical notations. This flow lines indicates the exact sequence of in which the statements or instructions to be executed. This shows how the statements are executing. The execution of the statements. This shows the execution of the statements or the flow of the execution. However, to avoid ambiguity, flow lines are usually drawn with an arrow headed. See, these have the arrow headed. So these lines are having the arrow headed. See, this is the arrow head. This is the arrow head. This is the arrow head. These are the arrow heads. And the last one is a circle, or we call it as the connectors. The circle symbol is also called as connectors. A connector symbol is represented by a circle, and a letter or digit is placed in the circle. See, in the circle we write the letters or digits to specify the link, between the flow or flowchart. So whenever a complex flowchart is to be drawn within the number of direction of flow lines, okay, is configuring, or it can long has over the more than one page. See, in some cases, if the flowchart is more than the size of the flowchart is more than one page, then we use this connectors, or then we use this circuits. Okay, to represent or to avoid the break of the flowchart. Okay, so these symbols are used to connect the flowcharts or from one page to another page. This will connect the flowchart from one page to another page. So let us see one example here. So this flowchart, here we are calculating or we are drawing the flowchart to find the area of a triangle. So whenever three sides are given, okay, then we are going to define or then we are going to draw the flowchart for the triangle. So here this is the start, this is the stop. Start, stop. These are called ovals, or we call it as a rectangle or rounded rectangle. Ovals, sometimes we write it as a oval or sometimes we can also write it as a rounded rectangle. So this is the rounded rectangle. Start, stop. So and here it is a paragraph. Paragraph are used for input and output purpose. So this is the input paragraph, this is the output paragraph. This is for output, this is for input. Okay, and these are nothing but rectangles. Rectangles represents the process of the data. So here we are processing the data. S is equal A plus B plus C by 2. We are processing or we are calculating S value. So the first step here, it starts the flowchart. It reads the values, that is the sides of a rectangle. Rectangle will have three sides. Okay, we are reading the values of three sides A, B, C. A is one side, B is the second side, and C is the third side. We are reading the three sides of the triangle. And then we are calculating the S value here. S is equal A plus B plus C by 2. We are calculating the S value. By using this S value, there is a formula. Okay, by using this S value, we are going to calculate the area of the circle. Under root of S into S minus A into S minus B into S minus C. So this is, we are calculating the area of the circle. Okay, this symbol source, rectangle symbol source. Okay, that is the processing of the data. We are processing the data. We are calculating the area by using this formula. And then we are printing the value. That is the area value. We are going to print the area value. Print area. And then this is the stop. Stop of the algorithm. Here it is started. Here it is ended. Okay, so this is the simple flowchart. Next example here. Let me see another example here. Flowchart to compute the factorial of a given number. So we are going to calculate the factorial of a number. Okay. So here this is the start of the flowchart, and here we are reading the value here. Okay, read n. We are reading the value from the user, and then we are defining a fact is equal to 1. A variable is defined as fact is equal to 1, and we are also defining the count value to 1. Okay, count value to 1. So here we are calculating the factorial. Fact is called fact into count. Okay, every time, okay, we are multiplying the fact value with count, and also we are increasing the count value by 1 for every iteration. That is, count is called count plus 1. Every time we are increasing it. See, if the count is less than or equal to n, okay, until the count value reaches to n, okay, we have to increase the value. If the value is less than n, if the count value is less than or equal to n, this n value, okay, then we have to continue the process. We have to continue the process. Okay, so normally the factorial is nothing but if 5 is the n value, factorial value is 5 into 4 into 3 into 2 into 1. So here the count value is to be checked as the value is reached until n or not. You have to check it. The value is reached up to n or not. Till then we have to continue it. If the value is not reached to n, then end the process. End the process. Okay. So this is the calculating the factorial of a number. Next example we see here. We are performing quadratic equation, or we are finding the roots of a quadratic equation. For a quadratic equation, ax square plus bx plus c is equal to 0, we have to find the quadratic equation. So here the quadratic equation will have the equal roots, complex roots and distinct roots. Three types of roots will be there. Okay, so it depends on d value, b square minus 4ac. This value, the roots, types of roots depends on the d value. If the d value is equal to 0, then the equation is having the equal roots. If d value is greater than 0, then it is having the different roots or distinct roots. If it is a negative, if the d value is negative, then it is having the complex roots. Okay, it depends, the type of roots depends on the d value here. Okay, so here this is the start of the flowchart and we are reading the values a, b and c. These are the values of the quadratic equation a, b, c. So is a is greater than b. So here we are checking the condition, is a is greater than b. If a is greater than b, okay, then the root values are nothing but minus c by b. Then it has one root, that is minus c by b. If a is not less than b, if a is not greater than b, then we have to calculate the d value. That is d is equal to b square minus 4ac. If this d value is equal to 0, then it has the equal roots. If the d value is greater than 0, then it has the distinct root. If the d value is less than the 0, then it has the complex roots. So what are the equal roots here? The first root is minus b by 2a. Okay, minus b by 2a. Another one is plus b by 2a. These are the two roots. Equal roots are there. One is minus b by 2a, another one is the plus b by 2a. So root 1 is nothing but again it has the equal roots. It has the two equal roots, root 1 and root 2. If it is a complex, or if it is less than, d value is less than 0, then it has the complex values. Complex values are nothing but a plus ib format. The complex root are in a plus ib form. Those roots are called complex roots. See, if d is greater than 0, then it has the distinct roots. What are those distinct roots here? Minus b plus root d by 2a. Okay, minus b plus or minus under root of b square minus 4ac by 2a. That is the general form, general mathematical form. But here we are making it as separate. Minus b plus root d. D nothing but b square minus 4ac by 2a. This is one root, and the second root is minus b minus under root of d by 2a. Actually, in mathematical terms, we represent it as minus b plus or minus. Plus with plus one root is there, with minus another root is there. These are the two roots. So when the d value is greater than 0. So at final, we have to print we have to print the equal roots. In this case, we have to print these distinct roots. For complex roots, here we are not finding the complex root here. Just we are saying that if d value is less than 0, it gives the complex roots. Complex roots are in the form of a plus ib. Those are called complex roots. Okay, so this flowchart explains finding the quadratic equation, that is the roots of a quadratic equation. So next we discuss about differences. Okay, next we discuss about the differences between algorithm and flowchart. Okay, so first difference is an algorithm is a series of steps. As we are saying from beginning, an algorithm is a series of steps that must be executed to solve a problem or to solve a particular problem. Okay, algorithm is a group of steps, or we call it as a series of steps. And flowchart is nothing but it is the pictorial representation of the algorithm. Flowchart is a diagrammatic representation or pictorial representation or graphical representation of a algorithm. Okay. And the second difference is it is hard to understand. Algorithms are hard to understand. Whereas a flowchart, it is easy. It explains the just flow of the steps. Flowchart explains the flow of steps, so it is easy to understand. Here in algorithm we use text. In algorithm we use text. Okay, or English sentences or phrases. We use sentences or phrases in algorithm. Whereas in the case of flowchart, we use the symbols. Those symbols are called graphical notations. Okay, graphical notations. And the fourth difference is no rules are employed. Here, there are no such rules. No rules to follow in algorithm. Whereas in the case of flowchart, we have to use those graphical symbols only. Okay, there are predefined rules are implemented. We have to use those graphical notations or graphical symbols to represent the flowchart. Other than those symbols, okay, we should not be using. Okay, you have to use only those graphical notations only. And the fifth difference is debugging is easier. Debugging is easier. Okay, finding the error, it is easier in algorithm case, whereas in flowchart it is difficult. Debugging is difficult. Finding the error, where the error is, finding that task of to finding the error is difficult in flowchart. And the sixth difference is it is difficult to write algorithm as compared to flowchart. So compared to flowchart, algorithm is difficult to write. See, whereas in the case of flowchart, it is easy to make the flowchart. So if you know the algorithm, then it is easy to draw the flowchart for that algorithm. But in the case of algorithm, the designing of the algorithm itself, it is a difficult. In the case of flowchart, it is easy. If you know the algorithm, then you can easily design the flowchart for that algorithm. Okay, so these are the differences between algorithm and flowchart. So let us see flowchart and algorithm at the same time. Okay, so at one side we are represented a flowchart, at another side we are represented the algorithm. Okay, so the first flowchart here it is performing addition of two numbers. Addition of two numbers. So here this is the oval symbol. This is the beginning. That is the beginning of the flowchart. Okay, and initialize the value of our of our memory variables a and b. See, we are initializing the values. A is equal to 20, b is equal to 10. We are initializing the values. Initializing means assigning some values to a and some value to b. That is called, we call it as the initializing. And then we are performing we are performing the addition, not multiply, it is addition. We are performing the addition operation between a and b, and then we are printing the value. We are printing the value on the screen, that is c is equal to a plus b. The result is in c. The result is in c. Okay, and then here this is printing the result, it is print c, and this is stop represent the end of the flowchart. Okay, so this is flowchart and algorithm. So this is another example is there. So this shows the beginning of the flowchart, and here we are reading the value m and n. We are reading two values here, m and n, and we are finding the greatest number or largest number among the two numbers. So here the case is that here we are checking the condition, that is if m is greater than n. If m is greater than n, then okay, print n is greater. Print n is greater. Okay, if the condition is false, then n is greater. If this condition is true, then m is greater than. If the condition is false, then n is greater value. And finally, we are going to stop the flow. So the same explanation is given here. If m is greater than n, then print m is greater. If this case is true, then print m is greater. Otherwise print n is greater. And then this is the end of the flowchart. So next we see another flowchart example here. So here this is the same. This is finding the roots of the quadratic equation. Okay, this example is for finding the roots for quadratic equation. So this is the start. Enter the values for a, b, c, and find the d value. Find the d value. D value is nothing but b square minus 4ac. B square means b into b minus 4ac means 4 into a into c. Okay, we have to write or we have to abbreviate like this. D is equal B into B minus 4 into A into C. And step 4 we are going to define or we are going to find the roots here. If D is greater than or equal to 0, then find the two roots are. If the D value is greater than 0, then it has the equal or then it has two roots here. One root is minus b plus the square root of d by 2a, that is the one root, and the root is minus b minus the square root of d by 2a. This is one root and this is another root. And then print the two roots, that is root 1 and root 2. Print the values. If d is not greater than or equal to 0, then print the roots are imaginary. See, if the d value is not equal to not greater than or equal to 0, then the equation will have the imaginary roots, and then it is the, in step 7 it represents the end of the flowchart. Okay, so it is the same thing which we have discussed in this algorithm is represented with the flowchart here. So start, read A, B, C values. Here we are reading the values A, B, C values, and we are finding the determinant D value, that is B into B minus 4 into A into C. We are finding the D value here. If D is greater than 0, if the case is true, then it is having the two roots, that is minus B plus square root of D by 2A. And second root is minus B minus square root of D by 2A. Okay, so this is the mod. The symbol is the mod symbol. Mod represents the positive value. Mod represents the positive value. And then print the root values. Print root 1 comma root 2. Okay, and then stop. See, if the case is not false, if the case is, if d is greater than or equal to case is 0 is case is false, then stop it. Okay, the same thing is like here. If d is not greater than or equal to 0, then print the roots are imaginary. Just you have to print the roots are imaginary and then end the flow. Stop represents the end of the flow. Okay, so in this way we are finding the roots of a quadratic equation. Okay, for that this is the flow chart and this is the algorithm. Okay, so by this I'm going to end the class. Thank you to everyone.